Hello and welcome to this demonstration video for SimuWorks, the custom dashboard interface for GPSX models. The GPSX interface was designed to allow users to construct models and access detailed information during the model building process. This is often too much detail for users who wish to run a limited number of practical operational simulations on a specific plant. SimuWorks allows us to remove the mathematical model from the more complex and generic GPSX interface and place it into a custom plant-specific one. In this way, much of the complexity of the GPSX building module is removed. This allows end users to be able to interact and use the model without learning the details of GPSX, and it allows us to make a very customized plant-specific front end. So let's take a look at some examples of different kinds of interfaces that we have created. This is an example of an interface we created for a client in the United States. And one of the highlights here is that unlike GPSX, the results of the model simulation can be placed directly on this schematic of the plant. By selecting from this drop-down menu here, the concentrations or flows or mass flows can be displayed directly on the image itself. So let's start a dynamic simulation here, and we can see that after it comes to steady state that while the dynamic simulation is running, the loading and the concentrations and so on are updated directly as the simulation proceeds. By right-clicking on this hotspot, we can access menus such as this step feed menu or the DO control for any one of the aeration units that are here to allow us to turn on and off the DO control or set the airflow directly, for example. Each one of the unit processes in the schematic allows us to have access to that input and output. And lastly, we have a number of pre-programmed scenarios for simulations set up in this drop-down menu here that cover typical situations such as wet weather events, operational changes, or even training scenarios for failures. Lastly, we also set this one up to allow it to have multiple plants, and you can access each one of the different plants in the same manner. This interface uses more of a top-down view to represent the different parts of the plant. It also allows users to right-click and access menus that allow different operational changes, such as turning on a DO controller and making changes to set points, for example. It also allows users to very easily take units in and out of service. As shown here, taking these secondary clarifiers in and out of service, the units become grayed out, and is a very sort of intuitive way for users to access the input to the model. There's a number of different types of scenarios that are available. So for example, users can run a summer temperature scenario here and take a look at the overall effluent quality from the plant. They can also change over to a wet weather scenario where something is going to be changing dynamically over time, and they can click on any part of the plant to look at the relevant data for that part. So here we're showing the influent, and we can see here that the influent flow increases over a period of time as the storm is passing through. Other outputs from the model can be plotted directly on the graph, and as we can see up here, we're looking at effluent TSS right on the schematic diagram. This interface involves the use of three different models that are hooked together. So the user can select from an overall map first to come to some particular part of the plant, select information to be displayed on the screen, and then run a steady state or dynamic simulation. In this particular case, the upper part of the screen is not as interactive as some of the other ones that we've shown, and all of the input is driven through sliders and typing in information into the menus down below. The information can be displayed on the upper screen, and simulations are run through the simulation bar in the middle, and all of the information that is provided for output comes in the lower left screen. You can pop back and forth between the models. As you can see, the simulation is still running, and we're still looking at outputs from the secondary stage of this particular plant. And all of the nomenclature used on the tabs and the input menus here is specific to this particular plant. using the terminology that the operators are familiar with. Here's another different sort of overhead view of a plant, again with the scenarios that have been pre-programmed in, as well as the ability to easily take units in and out of service and display the results of the model directly on the overhead schematic. So we're running a dynamic simulation here, but it's going to start from steady state, and that's just coming to convergence now. And as you can see, you can access the results from for any one of the unit process here by clicking on the relevant part of the plant to get the input menu, or indeed get the output menu if you would like to see the results in more detail. For each one of the places on the model where you can click and bring up some more input menus, there's usually several tabs available that have quite a bit of detail available about that particular unit process. So in this case, we can take a look at what the effluent quality is like when we take a few units out of service, as we've done with some of the other examples here. We can right click and deselect these particular units here. So we'll do something fairly drastic by taking several out of service, and we can see the effluent concentrations of BOD and COD are increasing over time. And then if we go back and put them back into service again, that's a good example of how a dynamic model can show the improvement in quality. So now everything's back in service again, and we can see the effluent quality improving as the concentrations themselves come down. So we have the ability to take things online and offline to change the DO operation in this plant, either using a control or specifying some airflows directly. If we enter in some numbers that are outside of the normal range that would be allowed, that can be highlighted and can be controlled so that users do not enter in numbers that are unrealistic for the particular performance of this plant. And lastly, this interface was designed with the goal of replicating an existing SCADA system. The model is connected to these images here that the operators are already familiar with, and the model outputs are placed into the same windows where the SCADA results would normally be shown. So users can come in and browse around. Ones that are already familiar with the SCADA system will know how to open up and menus, turn on and off certain pumps. We replicated a number of the alarms and other signals that come from their system. We are doing that from the model here. So again, the users can browse around, and in places where we were able to fill in the information from the model, we did that here on these existing screens. So the idea behind this was to allow a very ease of use for this for situations where people are already familiar with this SCADA system at the plant would be able to sit down and navigate around the model in exactly the same way. So, to summarize, SimuWorks is a custom plant-specific front-end interface for GPSX models, and it's designed to be specific to that particular plant. It can be as simple or as complex as needed and designed for a specific purpose. You can use any style of graphics using any types of images, and it allows users to be able to access and use a model without learning the details of GPSX. SimuWorks is typically used by our clients for operator training and development, where you can have a plant-specific operator training environment to use for education, for screening, for evaluation, and obviously it's a simulation, so it's in a safe environment with no risk to plant operation. It can also be used for plant analysis, for evaluation and optimization of the performance of the plant, for doing analysis and validation of new technologies that are coming in, obviously planning, forecasting, risk analysis, and so on. In any case, you can be using the model to do a prediction of what's going to happen at that plant under a different operational scenario.